In this lesson, we are going to look at adding fractions. We have 5 examples. This one is example number 1. We are asked to evaluate 3/4 plus 5/7. We can't add the fractions as they are because we have different numbers on the denominator. Hopefully you will remember from adding and subtracting fractions before that we need a common denominator. What we need to do is try and think of the lowest number that both 4 and 7 goes into. The lowest number that 4 and 7 goes into is 28. Often we can find the lowest common denominator just by simply multiplying the two denominators together. 4 times 7 is 28. This doesn't always give us the lowest common denominator. This time it does. So the number on the bottom of each of our fractions is going to be 28. But we need these fractions to be equivalent to the ones above. So how do we do that? Well, we have multiplied 4 by 7 to get 28 on the denominator. So that our fraction stays equivalent, we must multiply the numerator by the same amount. On the second fraction, to achieve 28, we have multiplied by 4. And to keep our fraction equivalent, we must multiply the numerator by 4 also. 3 times 7 is 21, and 5 times 4 is 20. So what we have now is 21 over 28 plus 20 over 28. Adding these together gives us 41 over 28. What we have now is a top-heavy fraction, and the best thing to do is change this to a mixed number. How many times can 28 go into 41? It goes once, and we're left with 13 28ths. What we need to do now is check to see if we can simplify the fraction part. Is there anything that goes into 13 and 28? The answer to that is no. So 1 and 13 28ths is our final answer. This is example 2. We're asked to simplify 2m over 5 plus 2 over n. So what we're looking to do is to add the fractions together, and we can't do that yet because we do not have a common denominator. If you think back to the last example, we found out that one way of getting a common denominator on the bottom is by multiplying the two denominators together. So 5 times n gives us 5n. So we have the common denominator of 5n now. So in order to get that, we have multiplied by n, remembering we must multiply the numerator by the same thing so that we have an equivalent fraction, and this one we have multiplied by 5. So multiply by 5 on the top also. So we have 2m times n gives us 2mn. And on this one, 2 times 5 gives us 10. And remember, we got the bottom by 5 times n gives us 5n, and n times 5 gives us 5n. So now we have two fractions with a common denominator, which means they can be added. So we have 2mn plus 10 over 5n. Our question asked us to simplify, so what we need to do now is check to see whether this fraction can be simplified. So at present there's nothing we can do to simplify. Often what we can do is factorize, and sometimes we can get something that can cancel. So looking at the top line, we could factorize that, so we'll give it a go. We might get an answer which can cancel with something on the bottom, we might not, but we should try it anyway. 2mn plus 10. Are there any common factors? 2 goes into both, so we can put that outside a bracket to factorise. So we've got 2 outside. 2 times mn gives us 2mn, and 2 times 5 gives us the 10 on the top. Put that over 5n, and on this occasion we haven't got anything that can cancel. We have 2 multiplying on the top and 5n on the bottom. So we can't simplify, so this one is our final answer. This is example 3. We have 3 over c plus c over 4. In order to add these together, we need to get a common denominator on the bottom, and to do that we can just multiply the two denominators together. So c times 4 is 4c. So our new denominator on each fraction is 4c. So how did we actually achieve that? Well, we had c, now we have 4c, so we multiplied by 4. Remembering we must multiply by 4 on the top also. And we had 4 on here, now we have 4c, so to achieve that we have multiplied by c. Remembering to multiply by c on the top also. So c times 4 gave us 4c, 3 times 4 gives us 12. And 4 times c gave us 4c on the bottom. C times c gives us c squared on the top. So the fraction can now be written with one denominator. It can be written as a single fraction. And we have 12 plus c squared on the top line. What we need to do now is check to see if it can be simplified. At present it can't be simplified. Sometimes factorising first can give us something that can then simplify, but there's no way to factorise the top either. So this is our final answer.